Hello everyone, today I will solve a B-level RC circuit problem using Prada and a simulation. So this circuit has a resistor of 200 ohms and a capacitor of 100 nanofarads and an AC source with amplitude 10 volts. So we need to find the voltage across the resistor and the capacitor at two different frequencies. So first of all, we recognize that this is a series RC circuit with alternating current. So this is series RC with alternating currents. So in this kind of circuit, the capacitor does not behave like a normal resistor. Instead, it has capacitive resistance which depends on frequency. Like this means at low frequency, the capacitor opposes more current. And when it is high frequency, it is less current. Next, abstraction. What we have in problem. So we know resistor, we know capacitor, and we know the voltage of the source. Let me write it. So it's our abstraction, like what we have. So next is decomposition, how we will solve the problem. Decomposition. So our main formulas look like that. Voltage equal I multiplied resistance, and voltage of capacitor is C multiplied current. So as you see, we don't have current and capacitive reactance. So that's why first of all we will find this capacitive reactance, then we will find current, then we will find voltages at different frequencies. So the formula for find capacitive reactance is 1 divided V. So we know the capacitance, but we don't know that omega, but we know the formula, which is 2 pi frequency multiplied capacitance. So we know frequency, we know capacitance, then we just put the numbers and calculate the capacitive reactance. So let's calculate it. So capacitive reactance will probably be, let me calculate it, maybe what? So it will be 637 ohms. Now let's find current. To find current, we will use the formula, which is look like that. Like under square root, we have plus. Let's calculate it. We'll probably have 15 multiplied minus 10 power minus 3 ampere. Now we can find voltages. It will be 15 multiplied. It's 200 ohms. It will be 3 volts. Next, capacitance multiplied current. It will be 15 multiplied what? 637 ohms. It will be 15 multiplied probably 9.6 volts. Oh no, I think for the B part you can solve this problem because you will use the same formulas. Now let me show this problem on FASTAT simulation. Yeah, on FASTAT simulation, the circuit will like exactly like as you see in the problem. So this is series RC circuit with the alternative current. So in this type of circuit, as I say, the voltage is divided between the resistor and that's our resistor and that's our capacitor. Yes. So now, as you say, it's at low frequency. It's 60 hertz. Now let's run this. So what you see at low frequency, the capacitor, this is a capacitor, has a large reactance, so it resists the current. As a result, most of the voltage appears across the capacitor. So as you see, it's resistors graph and the capacitors and this AC source. So now let me change the frequency. To change from 60 maybe to 100. Yeah. So when I increase the frequency, the capacitive reactance decreases. This allows more current flow through the circuit. So now, as you see in the graphs, the voltage across the resistor increases while the voltage across the capacitor is decreases. This happens because in series circuit, the voltage divides depending on impedance. So for short, our short conclusion for this. Now let me show like when we'll have. So we have to wait. Let's see in given of the problem. Let me apply it. So as you see, it's very fast. Maybe I will change the speed. But as you see, the graph look like that. So short conclusion for this problem. So as you see, at low frequency, the capacitor dominates the circuit, and at high frequency, the resistor dominates. So let's move to the next problem. Here our next problem. So in the figure shows a parallel RC circuit with an alternative current source. In A part, we should use a phase diagram analysis to find expression for the peak currents IR and IC of current of capacitance. Then we have heat, and the B part we should find peak MEF current. So first of all, the AC current through a capacitor leads the capacitor voltage by 90 degrees. On the other hand, the current and the voltage are in phase for a resistor. So now let me. That was our pattern recognition. Like this is a parallel RC circuit, and in parallel circuit, the voltage is the same across all components. As you see, that's here that we have same. They are the resistor and the capacitor in the parallel circuit, so the voltage is the same across all components. That was our pattern recognition, and for abstraction, we will focus like what is given. We have only resistor, capacitor, and the source of voltage. Yes, it's omega. So that's all we have, and then we should find currents that pass through the resistor and the current which flows from capacitor. So how we will find this? Now let's break the problem into parts. That will be our decomposition. So first we will find current through resistor, then current through the capacitor, and we will find the total current. So let me first show this on the phasor. Let me draw it. Now let me show this currents on the phasor. So first of all, we have that some angle omega cosine omega. That's why our also in parallel circuit components like have the same potential differences. As I said, the voltage phasor of both the resistor and the capacitor match the phasor of the MEF. So our like graph will look like that. So let me draw it. Maybe perfectly. Oh no. So let me draw it and I will explain. So that will be our current IR, and as I said, they're in like same phasor of at MEF. Then that's our I current which flows through capacitor. That's angle of like omega t. Now that's how it looks like on fader. So we should find I areas. So let's write our Ohm's law that all we know IR equals voltage divided by resistor. So we have resistor, and as I said that we have parallel circuit. That's why our voltage will be same. So it will be cosine omega divided by R. Next, our current flow that flows through this, it will be look like that. No, I'm lying. It will be like capacitive reactance. Okay? So it will be XC. As I said, it will be same voltages. Sine omega t divided. We know this. It's 1 divided c. So that will be omega c sine c. So that's how we will find the currents. Next, we should find the peak EMF current. Yes. So as you see, the graph that I drew, the currents are perpendicular. So we can use Pythagorean theorem to find the peak current. So it will be pi under square 3 plus square. So that's the problem is actually solved. That just put these values into that formula and we solve the problem. Now let me show it on the simulator. So here it's how look in Fastart simulation. So let's run this. Oh, maybe we'll add speed. Oh yes. Now that's like pretty look like an previous problem, but here we have parallel circuit. So as you see, their color is changing, and what is meaning? So the color changes represent the instantaneous voltage in the circuit. When the voltage becomes negative and the wires turn red, this shows that the alternative current source continuously changes polarity. So this also explains why current direction alternatives in AC circuit, which is important for understanding phase relationship in the RC circuit. So maybe let's play with a frequency. Maybe I add apply 100. So as you see at low frequency, the capacitor current is small. Yes, that's it, but it's instantly changing. And as I increase the frequency, the capacitor current increases. Now let me show it one more time. Maybe for this it's 10. Why not? So as you see, the graph is changed. So that's what I wanted to show you. So see you later.